On an average Tuesday, a doctor named Joe McFarter was sunbathing on a beach when suddenly he got a call from a hospital he works at. They had received a patient who had a terminal illness and was going to die in 1 hour. So Joe put on his clothes and started driving to the hospital. However, when he reached the hospital, all the gates were closed. The only way he could get into the hospital was through a cannon. He uses an app to figure out the amount of gunpowder needed to launch. Calculating less than the exact amount will result in the doctor falling short of the hospital. But calculating much more than the amount will cause the cannon to explode. The cannon is 88 meters away from the hospital, and the fourth floor is 9.1 meters high. What is the arc length of the path that the doctor will fly through? We should also note that the initial velocity of someone being launched in the cannon is 31 meters per second, and the cannon is at an angle of 45 degrees.
Alright, so we can model the doctor's path using parametric equations. We first used the uniformly accelerated motion equation to represent projectile motion, which is the doctor in this case. This equation consists of the initial position plus the x velocity times t plus 1/2 of the x acceleration times t squared. We know that the x velocity is represented by v cosine theta and that there is no acceleration in the x direction. Then we plug in our known values into the first equation to get that x of t equals v cosine theta times t. We then do it for the y direction, and we're given that y velocity is represented by v sine theta, and that y acceleration is gravity, which is negative 9.8. Then we plug in our known values to get that y of t equals v sine theta times t minus 4.9 t squared. We then take the derivatives of both equations to get that x prime of t equals v cosine theta and y prime t equals v sine theta minus 9.8 t. We are given the information that the fourth floor is 9.1 meters in height, the initial velocity is 31 meters per second, and that the angle of the cannon is 45 degrees. We then plug this into y of t and then solve t to find the amount of time it takes to travel to the fourth floor, which was about 4 seconds. To find the arc length, we take the integral from 0 to 4 of square root dx over dt squared plus dy over dt squared of dt to finally get that the distance the doctor traveled is 98.9 meters.